Hello, in this video I will show a quick tutorial on how to use PVStream electrical design module. Before we will start, I would like to show our hardware database, which inverters do we have in that database. So I've picked Azure inverters, a couple of advanced energy, Chint and Fronius and ABB. I need these set of inverters to demonstrate some of the features of automatic electrical design and some other features of PVStream electrical design module. Okay, so let's start. I have already pre-created a project. It is commercial property, flat roof. To save the time for this demonstration, I've already outlined the roof and outlined some obstructions on this roof. So the height is 10 meters. It is single tilt system, 15 degrees tilt, row spacing half a meter and 5 centimeters column spacing, and I will use these sharp PV modules. Okay, so let's do PV module layout. As you know, you can just move the slider here, or you can just type the number of modules here. One thing, I'm getting the negative savings because my energy bill is not adequate for this type of layouts. I didn't specify the build for this exactly property, so these are just a random bill, and obviously it's should be bigger in order to give savings for such number of PV modules. Okay, so we have a basic mechanical design here, laid out panels, and let's start doing the electrical design. So in PVStream, you can do electrical design in two ways. You can do an automatic design, which will place inverters, divide whole layout on strings, attach strings to proper MPPTs. Or you can do the manual design by placing manual inverters, draw the strings and attach manually them to inverters. But you can do actually a combination of both. So I would like to start with demonstrating automatic electrical design. And before we will generate the automatical design, the system should analyze the layout and understand which inverters will fit best for my current layout. By clicking this button here, I will initiate system analysis. Okay, so it's already done. And we have a list from our hardware database, list of inverters, which system thinks best fit to our current design. And this list is sorted. The top one will be the most efficient inverters for this particular design. Let me pick this one, click generate, and here it is. The electrical design has been done completely automatically. So let me describe you this a few things here on the electrical design. So first of all, you notice that the whole layout has been divided on string. Each string has its own color code, so there is string color coding. The string starts, I can show on this one, for example, with this triangle. It is the beginning of the string. You can see also the label of the string, and this line shows how the string is going. You can select the string here to highlight the modules which are part of this string. So the whole breakdown happens automatically, and the number of modules per string has been calculated by calculating first the minimal, maximal number of modules per string, which depends on your geographical location, on your climate conditions. Then it picks within that range of minimal and maximal number of modules, the number of modules which allow to cover maximal amount of modules in layout with strings. So we have here on the right part the property pane where all inverters, added inverters are listed. For every inverters we're displaying the module, DC-AC ratio, the output, number of phases, voltage, AC current, input DC, and list of MPPTs for this inverter. This inverter has two MPPTs, and inside every MPPT you see its parameter, DC voltage, current of DC current for that MPPT, and DC power, and also the number of strings here. And when you select the string here, it is also displayed here in the property pane. Or you can actually do vice versa. You can select the string here and it will be centered. If you don't like this color coding, you can turn it off by opening layers menu and disable string module color coding. But I find it very useful. So you can do changes in the automatic design, and basically you can modify mostly everything. So for example, I have a string here. For example, I don't like how it is going and I would like to change it. So first of all, I need to delete it. So those modules are unstringed. And I can add them back by either adding them automatically by clicking this button for the MPPT. This will link all available modules to these MPPT, and this will again create this string, but let me delete it. Or you can manually draw the path for that string. For example, I would like it to be started here, go here, and you see as I'm drawing, the system is trying to construct the strings by the modules which are already selected by my line here. So far I have 0 strings because number of modules per string for this MPPT should be 24. So in order to form a string, I need to select 24 modules. Okay, from here to here, from here to here, from here. Okay, it was highlighted with green. This means we already have one string. Now clicking the mouse right button, I'm finalizing creation of the string. Okay, so now the string goes exactly as I've drawn here. I can do more changes here. I can clear entire MPPT. For example, I would like to construct this MPPT differently. So you saw all strings attached to this MPPT has been removed. Again, I can manually attach all the unattached modules to this MPPT. This will cause the string breakdown again. Automatic string breakdown, module breakdown by strings. But I can also do everything manually by clicking this button, draw string. Again, clicking on it, I'm entering the drawing mode, and all I need to do is draw the path of the string. So now I have already 2 strings, 50 modules selected, that is 5 strings. And when I'm drawing, the system is trying to break down to strings as much modules as possible. It uses again the range of the minimal and maximal number of modules per strings, and within that range it picks what would be the most optimal number of modules per string in order to break down to string as much modules as possible. But I will continue selection here. So we still have 5 strings, but we already have 15 modules per string. And the system basically shows you guides here in that tooltip that you have selected 2 extra modules. You have 4 strings, 23 modules per string, 2 modules extra. So we need either to add 20, I select 21 modules more or remove 2 modules. Okay, but I don't need more. And to finalize the string draw procedure, I need to click with my right mouse button. Okay, so the strings has been created, and you saw they are going exactly how I've drawn them. And also you can override the path of the wires. So those blue lines here, these are string wires which connect strings with inverters. So for example, for this string, I would like to override how the wires are going. So what I need to do, I need to click this button. It's update wiring. When I'm clicking this button, I'm entering the wire drawing mode. So first system asks me to click the one of the string endpoints, clicking on it, and I'm starting to draw the wire. For example, I would like it to go from first to here, then to here, and then I need to connect it to inverter. Then I need to select the second end of the string, and I would like it to go from here to here and then to here. So for this string, we have updated the wires. And definitely you can completely remove this inverter and do everything manually. So to remove inverter, you can click here, or just press delete button on your keyboard. Okay, let's delete the inverter. And let me do the design completely manually. Let me add an inverter. This button is add inverter here. Let me select the module. Well, actually I can, let me use this inverter. It has 2 MPPTs, and I would like to manually start attaching strings to these inverters. So I will again start from the top, and I will start draw the strings. So the string should go from here to here, and as you see that as I'm drawing, it's already trying to construct the strings from here to here, from here to here, and the system will not allow you to add more strings to MPPT than possible. Then I would like to go here. So I already have 3 strings, but I think I've selected too many modules. Yes. Okay, so this MPPT has 3 strings and number of modules per string is 24 here. Let me also attach strings to the second MPPT. Okay, I would like to go from here to here, here, then here. We will string these modules. Okay, looks like I've also selected too many modules. Again, the system is checking every user's action and is not allowing to overload particular MPPT. Okay, let me add the second inverter. Oops, no, not the not the automatic design, but this button here. So here is the second inverter. Okay, so I would like the strings to go from here to here like this. So probably I've already selected too many modules. Okay, so for the second MPPT, we'll add these modules. I wonder if I can actually add more strings to this second MPPT. Let me try to link all available modules. No, that's maximal. And let me add a couple of smaller inverters. I will pick a different inverter model. Let it be this one, this Fronius. It has only one mppt and it's rather relatively small inverter. I'm not sure I can add more. That's probably only one string. And the second inverter. Actually, I would like to choose different one. And this string will go to this inverter. Okay, so sometimes it's not possible to link all the modules in your design to inverter, especially that sometimes happening during the automatic design. So usually I'm removing these modules from my layout if I have one or two modules left, because of the number of modules per strings limitations and the mppt capacity. I definitely can add one more inverter here and attach all remaining modules here to those ones. Okay, so in general I have finished electrical design. So I have all the information about the design here listed per inverter. Uh, I also can view the same design in a single line diagram mode. So basically this is everything what we've been adding to these designs. So these are all the inverters here. Uh, so this first one, the second one, the third one and the fourth one. For those inverters which have multiple MPPTs, they are outlined here, and basically which strings are connected to which are also can be observed here. And I can also view the strings as I'm selecting some items here on this diagram. They are also selected here in the properties panel. And definitely I can export all these to PDF. So let's export this one to PDF. Let me select A3 pre-precise. Okay, here it is. And this is my single line diagram. And let me switch back to design view. I can export it also to PDF. Let me select different orientation and A3. And let me export also this module tilt arrows. I can actually control what to export. To export whether I would like to export the string names, inverter names, I can switch it on or off. This is the my electrical design. And I can also export everything to Excel. So in Excel, we're exporting the information per inverter. Here, every inverter is displaying its own sheet. And for every inverter, we're displaying the general inverter parameters and the string table, list of strings, which is divided by MPPTs, and it is done for every inverter. In general, this is all I wanted to show today. These are basic set of features for PVStream electrical design. As you noticed, it can be done in two ways, in the fully automatically or manually by adding inverters or the mix of both. Thank you for your attention. If it will be required, I can record more detailed video about PVStream electrical design features and other PVStream features. Thank you for your attention.